Okay, welcome back to another one of the GCSE Maths lessons. Today, by popular request, we're going to be doing circle theorems, which tend to be quite a tricky and confusing topic for GCSE Maths. So here I just have an image from Third Space Learning. So this just kind of summarises all of the different circle theorems, but honestly the best way to learn them is to actually use them. So what I'll do is, as we're going through the questions, I'll scroll back up and show you which circle theorem we're talking about. Okay, so one thing that we should kind of go over is, and I'll go over as I'm doing this, is what these different words mean. So first of all, we have the alternate segment theorem, which is a bit of an obscure one that people forget. So the angle that lies between a tangent and a chord is equal. So all it means is this thing here, BC, is a chord. And obviously this line here is a tangent because it touches the circle at only one point and it's a straight line. If you have a chord and a tangent, the angle created by them is always going to be equal. And I'll show you a few examples of that as we kind of go forward with this, okay? At the center angle theorem, this one has a few different names, but it's actually, in my opinion, one of the kind of more easy ones to remember. Essentially, if you have an angle at the center of a circle, it's going to be twice that of the circumference. But the lines joining them have to meet at the same point. So if you look here, the angle that makes up the angle at A, right, so this angle here, touches the same points as the angle that goes from the center. So that's the key thing to remember. It's not just any angle at the center is twice any angle at the circumference. It has to be made up from the same points. And as we go through circle theorems, you'll realize, and hopefully start to pick up, that generally speaking, we're always talking about angles that are made from touching the same point. Okay, generally speaking. Okay, speaking of the angles in the same segment, if you look, this one looks a bit confusing, but all it's saying is if you take 2 points on a circle and create 2 angles from them, they will be the same. Okay, so if you just were to create a circle here, and if you take 2 points on the circle, and if you make 2 angles from them, it doesn't matter where they are, they're always going to be equal. Okay, so again, just like in this previous one, if you take 2 points on a circle and create 2 angles from them, they're going to be the same. However, if one ends up at the center, it's going to be twice as big. Okay, so hopefully that's okay so far. The next kind of major one is, honestly, this one doesn't come up that much, but if you have a chord and the radius, they always meet at not only 90 degrees, but they always cut each other in half. Okay, so the chord is split in half. Okay, so I'm hoping that's all okay so far. And 2 more. So the reason why I've skipped over this one is it's very rare, right? But essentially, if you cut a circle in half and you create an angle from the ends of the line, so it has to be in the middle, you get a right angle. So another way to think of that is if I take the diameter of this circle, which you can see is the line AB, any angle I create is always going to be a right angle. Okay, so if I again create one over here as well, it's always going to be a right angle. Okay, so again, take the diameter, make an angle out of it, it's always going to be a right angle. Okay, and again, I'm going through these quite quickly because I think the best way to learn is by using them. Okay, but then you have a cyclic quadrilateral. So a cyclic quadrilateral is a quadrilateral that has its corners on the circumference. Okay, so it has to be like this. And all it says is that the opposite angles add up to 180. So if we were to label this one y, the opposite angle would be 180 minus y, because they add to 180. The key thing here that I see students make mistakes on is that they'll have these 3 points on the circumference, but the 4th one will be in the middle, and they'll say it's a cyclic quadrilateral. No, it has to have all 4 points touching the circle. I promise there's only one more, and then we can get on to doing some questions. I know it's a lot to take in, but as we do them, it'll become easier, I promise. Tangent of a circle. First one is that the tangent of the circle and the radius of the circle always meet at 90 degrees. And because of that, 2 tangents from the same point are always the same length. Okay, so those 2 actually fit the same description, okay? So radius tangent, 90 degrees. 2 tangents from the same point are equal. Any questions on that so far? So I'll give you a few seconds to ask any questions. So again, it's a lot to take in. I don't expect you to remember it straight away. We're going to do some practice questions, okay? And I'll keep scrolling up to show you what I mean and where it comes from. Splendid. Okay, let's get on with it then. So scrolling down, here's our first kind of circle theorem question. It starts off easy and gets harder as we go along. Okay, so just keep that in mind. If you're finding this easy, then that's fine. Just stick around and we'll do some harder questions. So we have B is a point on the circumference of the circle centre O. AB is a tangent. And we have angle BOA is 72 degrees. Work out the size of angle BAO, which is this angle here, which I'm going to call X. Okay. Now, if you remember the circle theorem we just did, the radius always meets the tangent at 90 degrees. So if I go down again, this is the radius because it's a line going from the middle to the circumference. and that's a tangent, which means this angle here is a right angle. So all we're doing now is doing 180 minus 90 minus 72. So 90 and 72, so it's 180 minus 162, which is 18 degrees. Good. Okay. So that's a very good question, Lila. So do you need to write down the entire rule for the workings? So realistically, in the actual mark schemes, if it's a question like this, you don't need to write down the rules. However, in this next question, it says give a reason. Then you have to write the entire rule. But for questions like this, you don't need to write the entire rule. I probably will, just to show you, to explain to you, but you don't need to write it. In a lot of mark schemes, they accept that if you just label it, it's fine. Okay? So you don't have to. But it's sometimes good to just say what it is, okay? But you don't have to at all. In fact, that's actually why circle theorems are really tricky for GCSE, is a lot of the mark schemes have no explanations. They'll just write something like angle AOB equals 90 or whatever, and they won't explain it, so students don't know how they get that. So you don't actually need to write the rule. But for the next question, we do. So, if you have a look at this, I'm hoping that this is triggering your memory as to what this is. But A, B, C, D are points on the circumference on the circle, which is interesting because there's no point D. But anyways, angle BOC is 66. Find the size of angle BAC. So we're looking for this angle here. Okay. Now hopefully this is triggering your memory a bit. This setup looks like this rule here. Because if you remember, they're made up, both angles come from 2 points on the circumference, right? And the angle at the middle has to be twice that at the circumference. So if we look here, as we can see, both angles are made up of these 2 points, which means this angle here at BOC has to be twice that at the circumference. So we just need to half it and we get 33 degrees. Give a reason for the answer. Well, now we have to say that the angles, so angle subtended at the center of a circle. The wording doesn't matter as long as you kind of say it, right? At the center of a circle are twice the angle subtended on the circumference. I promise you I haven't misspelt circumference. That just looks like an A. It's meant to be C-I-R-C-U. I mean, so yeah. So that's the only time you have to write the full rule, is if it literally says give a reason for your answer. Or if it says give a reason for each step, then you have to write the whole thing. Okay? Any questions about that? Or is that all okay? I think that's alright. So again, it's starting off easy, but I promise you there are some really hard questions towards the end. Okay, and we'll get through all of them, I promise. All good, perfect. Okay, so again, this setup might be triggering your memory a bit as to what we just did, as in at the beginning of the lesson. So B and C are points on a circle, so we can actually probably mark those points a bit here. Okay. AB and AC are tangents to the circle. Angle BAC is 40. So BAC, that would be this angle here, is 40 degrees. Work out the size of angle BOC. So basically what they're doing here is they're drawing a line from here. And we have to work out the size of this angle here. Okay? So that's what the overall question is asking us to do. In fact, I'll label that angle X as well. Okay? Just so you know, a bit later on I will be using different colours to show you different shapes, because it can get it gets a bit messy later on. Now if I look at this, it looks very similar to this rule over here. So first of all, these tangents will meet that line at 90 degrees, and they're also the same length. Okay? So if I go back down, whoops, a bit too far. Because this is a line from the center of the circle to the edge of the circle, it must meet at 90 degrees. Okay? Now, this is a four-sided shape. Four-sided shapes, the total angle should be 360 degrees. So all I need to do is do 360 minus the 40 degrees here, minus the 90 degrees, and minus another 90 degrees. Okay? 1990 is 180, so 360 minus 180 is 180. That should be 140 degrees. Okay? So again, these first questions are just showing us it's quite basic. It looks like the rule. You need to use the rule. That's it. Okay? But they do get trickier later on. Before we move on, I just need a drink. Okay, perfect. So, next question. This is where things get a bit trickier. Because, I mean, look at this. Look, this looks crazy, right? It looks really, really weird. So, ABCD are points on the circumference of a circle. And CAD is 62, ADB is 51. Find out the angle ACB. So ACB is ACB. That is this angle here. And what we need to do is show that. Well done. That is correct, Lila. We are going to be using the alternate angles. It's. Let me show you which one it is. I don't know why I'm scrolling like a peasant. It's going to be angles in the same segment. So not the alternate segment, is actually in the same segment. Okay? And I'll show you the reason for that. Okay? So if you meant angles in the same segment are the same, then you're correct. But it's not the alternate segment. Here's a way that you can kind of remember that. Alternate segment has to have a tangent. Okay? So if we scroll back down to our question, there's no tangent here. So it's not alternate segment. Okay? So not the alternate one. But it is angles in the same segment are the same. Okay? So which angle is in the same segment? It's actually 51 degrees. And I'm going to explain that a bit better in 1 second. So all you need to do is say angles in the same segment. Okay? And just to explain that, because so hopefully that makes sense. First of all, it's going to be angles in the same segment because there's no tangent. For the alternate segment theory, you have to have a tangent. So the question is, why is it 51 and not 62? Well, they're made from the same segment, right? Now, the segment, actually, let me use a different color just to make this clear. The segment we're talking about is this segment here. Now, can you see that these two angles here, hang on, let me go back to the pen quickly. These two angles here are both made up of these 2 points here. Remember, for that almost all of our theories, the angles have to be made from the same points on the circumference. So if you look, this line here, right, and this line here are made up of the same points, which means this angle has to be 51 degrees because they're made of the same segment. And remember, a segment is just like a slice of a circle. That's a bit tricky. Okay, so if it doesn't make sense, let me know and I'll explain it another way. That's only one of the ways I can explain it. I can explain it in a few more. Does anyone want me to explain it in a different way? Or has anyone got any questions? So lost. Okay, yeah. I knew this one would be a bit tricky, okay? That's totally fine. So, if we have a look back at the original question, right? At the original theory. Can you see? So this is the angles in the same segment. can you see that they're both made up of the same 2 points on the circle, right? So both of these guys have a line coming from D and a line coming from B. That means they're going to be in the same segment. A segment is just this thing here. It's like a piece of a circle. Okay? Does that make sense so far, Lila? So again, they both have lines coming from the same points. Yeah? Good. Now if I go back down to our question, which I'm guessing is where the confusion's coming, both of these angles here, so this angle here and this angle here, have a line coming from A and a line coming from B, which means they're in the same segment. Okay? So if I draw it in another few colours, let's use different highlighters. From B we have that line here. And if we do it for the other one, let's use a very garish pink. Oh. So they both have lines coming from the same 2 points on the circumference, which means they must be in the same segment. As you know that yellow area, they both share that area. Okay? So now does that make sense? So it's the same thing as, yeah, perfect. It's the same thing as before. It's just really hard to picture it in your head, right? It's really, really hard. But as you practice, you'll get better at it. I admit it's very hard to see. Very hard indeed. But I'm glad that you get it. Perfect. Next question. Again, this is just using like the standard ones. So we have A, B, C, and D are points on the circumference of a circle. Angle BAD is 94 degrees as they've shown here. Angle ADC is 83 degrees shown here. Now there's a four-sided shape, so we're probably thinking cyclic quadrilateral. Because all 4 points are touching the circumference. That's a really, really important part, okay? All 4 points have to touch the circumference. And if we go back up to our rules, what's the rule with cyclic quadrilaterals? The opposite angles add up to 180. Okay, so if we go back down here, if we were looking for the angle ABC, that is going to be this angle here, ABC. The angle opposite is 83 degrees. So if we do 180 minus 83 degrees, we get 97 degrees, which is our answer. Okay, and the reason is that opposite angles and this is the only time we have to write out the rules in full in a cyclic quadrilateral. Don't say they're equal, they add or sum. Degrees. Okay? But again, something that I always see the problem I see students make, the mistake, is that the last point might not be on the circumference and they'll say it's a cyclic quadrilateral. It's not. And you get the wrong answer. That all good? I think these ones are so far so good. Perfect. Okay. Here we go. Okay. This is one where it's not really a circle theorem question. Okay. You actually do this without using circle theorems. Okay. So, if I have a look at this triangle, right? It's made up of a chord here from A to B, and made up of these 2 lengths. Now, these 2 lengths are very interesting. Okay? They are equal to each other because they are both the radius. Okay? Why are they the radius? Because they're going from the center of the circle to the edge, which is always a radius. Okay? So from the middle of a circle to the edge is always a radius. So if those two things are radii, then this angle here has to also be 48 degrees, because this is now an isosceles triangle. Remember, an isosceles triangle has two sides equal, which means the two base angles are equal. Now if we're looking for the angle AOB, that's this angle here, which again I'll call x. X is just going to be 180 minus 48 minus 48. So that's the same as doing 180 minus 96, which is 104 degrees. Okay? Is that okay? The hard bit is now the reason. The reason can be a bit tricky. We actually use two reasons. One, perfect, good. So in terms of the reasons, give a reason for your answer. I would actually give two to be safe. But the first one is that the angles in an isosceles triangle are equal. Technically, I wrote this wrong. I should have written base angles here. And the second reason is that angles in a triangle add to 180. Okay, and that's it for the reasoning, okay? So that isn't really a circle theorem, but it is a very, very, very common thing that comes up in circle theorem questions, okay? This comes up a hell of a lot, okay? And funnily enough, a lot of the questions, whenever students come to me and they say, I'm stuck on this question and it's like a circle with a triangle, 9 times out of 10, they forget that the radius is here. I'm covering all the circle theorems, yeah. We've gone through a few already, okay? So if you want, at the end, I'll do a bit of a summary. But we've gone through most of them already. Okay? Perfect. But I will go through them once again at the end. Okay, so we've covered all of the basic circle theorem questions. So now it's going to get a bit trickier. Okay? This is where they start kind of bringing them all together. So what we're going to do is just be, take it step by step and make sure we're all okay with it, okay? So, here's the first thing we need to realise. Actually, let's read through the question. I'm getting ahead of myself. A and C are points on the circumference of a circle centre O. AB and BC are tangents to the circle, and ABC is 46 degrees. Okay, cool. Find the size of angle OAC. OAC is this tiny angle here. Okay, so I'm going to call that X for now. Okay, OAC is going to be X. Okay, that's quite a lot to take in, but let's have a think. Well, there's a circle theorem we can use to do with tangents from a common point. Okay, so if I go back up to our circle theorems. Okay, isosceles triangle, well done, Evie. Remember here, tangents from the same point are equal in length, and they meet the radius at 90 degrees. We're going to be using both of those, okay? So let's go back down. So basically these two sides here are equal, okay? Which means that these two angles here are equal because, as Evie just said, it's an isosceles triangle because it has two equal sides, okay? So now we've got quite an easy job to do. All we need to do is do 180 minus 46 and then half it because the other two angles are the same size. So let's do it. So we've got 180 degrees minus 46. That would give us 134. And then if we half that, we get 67 degrees. Yeah, 67 degrees. Okay, so these two angles inside are 67 degrees. Now here's where things might get a bit difficult to see. I said we're using two circle theorems, right? The other one was that the tangent and the radius meet at 90 degrees. So in other words, if I were to Take away from 90. Well done, Lila. Perfect. Because this whole angle here is a right angle. Is everyone else okay with that? So, Lila, I know you're okay with it, but Evie, are you okay with that? And everyone else? Okay. So, x is just going to equal the 90 degrees from the right angle, take away 67, which is 23 degrees. It says give reasons for each stage of your working out, all right? And it is a 4-mark question. So there's 2 steps. So you get 2 marks for the steps, and you get 2 marks for the reason. So this one, the reason I'm going to say is that the base angles in isosceles triangle are equal. And this last step, it's because a tangent meets the radius, or the radius and the tangent meet at radius and tangent meet at 90 degrees. So you get 2 marks and for the actual working out, and 2 marks for the reasons. So we got 4 marks, pretty quick, not too bad, I don't think, but it's hard to spot, I think. Is anyone unsure of that? I think it's pretty okay so far, right? Got a lot more questions to get through, so don't worry too much. Okay, I think that's okay then. Okay, so question 8. A and B are points on the circumference of a circle centre O. DCE is a tangent. Cool. ACD is 76 degrees. Find the size of angle ACO. So ACO, what we need to do here is actually make... Actually, I probably didn't really need to do that. Not yet, anyway. Whoops. That was a disaster. We're looking for this angle here. Okay. Now, this one is very similar to the other one. This is the radius, and this is a tangent. The whole thing should be 90 degrees. Okay. So what we're doing is doing 90 minus 76, which is 14 degrees, which is our answer. But we need to give a reason, because radius and tangent so this is actually how I'd recommend studying and learning circle theorems yourself, is to actually write out the reason for every step of your working, even if you don't have to. Okay? It just helps you kind of explain it to yourself. And for part B, find the size of angle ABC. So ABC, that is this angle here. Let's call it X for now. Okay? So, Lila, earlier on, you mentioned the alternate segment theorem, but we actually used the same segment theorem. Well, the reason why we didn't use the alternate segment theorem is because we didn't have a tangent. In this case, we have a tangent. And we have a chord. So we're going to be using the alternate. Oh, whoops, that was strange. Segment theory. Okay, so if I scroll up just to kind of prove that what I'm saying is accurate. Oh, God. Okay. To prove that what I'm saying is accurate, is if you look here, this is the alternate segment theorem. So the angle that lies between a tangent is chord. Honestly, ignore the wording. The wording's horrific in my opinion. But when we have a tangent and a chord, the angle made by the chord and the angle made by the tangent are the same. Right? So can you see these guys are opposite each other? They're the same. These two angles would also be the same. Okay? So if I go back down to the question, if you look here, we have a very similar setup to the second thing I said. So x is actually going to be 76 degrees. Oh, I should have written it down here. So that's one of the harder circle theorems to use. So if you have any questions, please feel free. There are other ways I can explain it and everything, okay? But we have a chord and a tangent, and the angle made by the chord is the same as the tangent. Yeah, sure. So the way I see it, unfortunately this thing's going to get in the way. Oh god. All right. I'm going to have to delete that for a second because it's getting in my way. So if let's clear this out completely, right? This is a chord, and this is a tangent, right? If you ever have a chord and a tangent, and you want the angles next to them, then you should immediately think alternate segment theory. Right? So in general, if you ever see a chord and a tangent, think alternate segment theorem, okay? Now what it states, and it's very complicated, but the angle made by the chord is the same as the opposite angle on the tangent. So can you see that this angle here is opposite 76? Right? It's like looking away from it. It's going away. Okay. Does that make sense so far? Again, the annoying thing is if you ignore the line from O to C, it's easier. So try and ignore the line from O to C. In the same way that this angle here is opposite this angle here and would be the same. Okay? But in general, chord, tangent, alternate segment theory. Okay? That's what you should think about. And then you might be able to spot it a bit easier. But then all you're doing is looking at opposite angles, right? Cool. Okay. I'm glad. Perfect. So well done for asking questions, by the way. Stop me the second it doesn't make sense. I can explain it in a different way. And apparently it's good for you, which is perfect. And now we get into the big questions, right? I mean, these are, 4 or 5 marks. Looks a bit scary, right? There's about 1,000 things going on. So what you need to do is take a step back and take it slowly, okay? Take it nice and slow. There's a few things I'm seeing already. I'm seeing tangents and radii, right? So what I like to do is I just immediately start labeling, right? Even if I don't know what the question is, these two tangents are the same length. Yeah? Remember, tangents from one point, same length. Radius meets the tangent 90 degrees, so I can label that immediately. So those are the things I'm thinking about. Okay, let's actually look what the question is now. A, B, and C are points on the circumference of a circle centre O. B, D, and C, D are tangents. Cool, we've labelled that. ODC, they've already given us that, is 26. Find BAC. So B to A to C is this angle here. Not bad. Pretty good. Now, can you see that this top triangle here, BOD, is identical to the triangle ODC? Identical. Because they also share this middle length. So I can start labeling that this is also 26. Yeah? Okay so far? So I'm going to stop that for a second. I was going to keep labeling, but there's a thing that I've kind of thought that might make more sense. We should probably say what circle theorem we're going to use to get our final answer. Getting this is not possible directly. But if I look, an angle that I can work out is this angle here, right? And that's made up of the same 2 points, B and C, as angle A. So if I go back up to my circle theorems, if I have 2 angles made by the same point, it generally means I can use a circle theorem. But if I look here, the angle we want is on the circumference, and we can work out an angle from the center. And the relationship between that is the angles at the center are twice that at the circumference. So let's have a look again. Whoops. This angle here is at the center, which means it's twice as big as the one on the circumference because they're made from the same points. Okay? Does anyone have any disagreements about that, or is anyone unsure? All good? Perfect. Perfect, okay. Again, stop me the second you don't get it, Lila. Okay. So, okay. I'm going to redraw this, and please bear with me, my drawing skills are not very good. Oh, see? I'm going to redraw this situation, okay? Point B. However, I'm not going to draw the tangents. Now, can you see that this thing on the right is just this thing on the left without all of the tangents and stuff? Like, I'm getting rid of everything to the right of this. Do you agree with that? Yeah, cool. So this looks like the circle theorem that says that this angle here is 2 times the angle here. So because it looks like that, if I work out what this 2x is, I don't know why I made it a time sign, that's a bit stupid. All right. Do you agree with that? Got it in one. Well done, Lila. Perfect. That is exactly right. So there's actually 2 ways to do it. Lila pointed out one. We can say that this is one big 4-sided shape. So all the angles should add up to 360 degrees, right? So it's a big 4-sided shape. So let's do that. So 360 minus, and then the angles we have are 90 and 90. So minus 90, minus 90, minus 26, minus 26. So that's the same as doing... Oh, why am I struggling with this? 128 degrees. There we are. I was worrying. Okay. So this angle in the middle here is 128 degrees. So this angle at A is half of that. And Evie, is that all okay with you? In terms of reasoning, what I would say is angles in a triangle add up to 360. And for the last part, you would just say angles subtended at the circumference are half angles. So you have to write it in full, but I am getting a bit lazy, so I'm writing a bit like a caveman. But I hope you get the idea. Generally speaking, there's only one circle theorem question anyway, so you won't ever have to really write this like a bunch of times. Okay. So write it in full. I've written it a bit shorthand because I'm being lazy. Yeah, so that's all. It's all good. Well, I'm glad that you guys are understanding this so far. These are some of the harder questions, so it's good that you get it. Okay. So, for the next question, we have something that looks... Oh, yes, sorry. So, it's 1 mark per step. So, 1 mark, 1 mark. Yeah? and then 1 mark per theorem as well. So 4 marks in total. 1 mark for each step, 1 mark for each reason. I forgot to mention that. Apologies. Cool. So, A and C are points on the circumference of the circle centre O. BC is a tangent. Cool. CAB is 29 degrees. Find the angle of ABC. Okay. This is the angle we're looking for. Okay. So this is pretty innocuous. It's not very obvious what we should do first. And I believe this is going to be a 3-mark question or 4-mark question. Good. Bit tricky. Because we don't really know much information. Okay? What would be ideal is if we knew like this whole angle here or something. So here's what I would do. We have the center point here. I could draw a line here, right? And now that makes an isosceles triangle, right? So this is isosceles, and this is now a right angled triangle. Okay, which means this angle here has to be 29 degrees because it's an isosceles triangle. The base angles are the same. Is that okay so far? Okay, I think that's good. Perfect. So now I can work out this angle here. I'm just going to call it y for now. Y is just going to be equal to 180 degrees minus 29 minus 29. So that is 180 minus 58, which is 122 degrees. Okay. So now I can work out what this angle is. The reason why I'm doing this is because to work out this angle here in a triangle, the easiest thing to do is to have 2 other angles and subtract it from 180. So that's where my thought process is going. So I'm going to call that angle Z, I guess, right? So now Z is 180 minus 122, which is 58 degrees. So now angle X, once again, angles add up to 180, so we just have 180 minus the 90 degrees from the right angle, minus the 58 degrees from the angle Z, which gives us 90 minus 58, which is 32 degrees. 4 marks. I think the trickiest bit is knowing to draw that line here. After that, I think the question will become is fairly easy. But before that, getting to that first bit is hard. The reason why I knew to do that is because I already have one side which is going from the center to the circumference. So this is already the radius, right? So I can make another side with the radius. It makes my life easier. That's the logic I used. Okay. Lila, are you okay with that as well? Evie, are you okay with that? Or are you just saying like you kind of get it? Again, this was a really tricky question. There's a reason it's 4 marks. It's not because you're subtracting from 180. That's too easy. The hardest bit was the initial starting bit. Yeah, good. Let's keep hammering through. So, what's the first thing? I'm not even going to read the question. That's a chord, right? That's a tangent. So before I even know what the question is, I'm thinking alternate segment theory. Do you see how quickly I saw that? Yeah? It's just wired into my brain. Okay? So that means this angle here is the same as this angle here. And this angle here is the same as that angle here because it's opposites. Okay? And it looks like we're working out x, so that's perfect. Does that make sense? How I knew, just saw it immediately? Give you a second just to process that. We don't have to rush. We've got time. Sweet. Perfect. So there are two ways to do this, but they're actually the same calculation. So either angles in a triangle add up to 180. So we do 61 minus... Or, so that is angles in a triangle, right? But if you also look, these three angles here are on a straight line. So they would also add to 180. So it's the same calculation, which makes sense, right? Because those angles are the same. They have to be the same. So they have to have the same numbers, right? So I'm going to just put a slash, angles on a straight line add to 180. So one question I actually saw in a GCSE paper, I can't exactly remember what, something quite interesting. They gave you one reason. So they said like angles in a triangle add to 180. And they said, what is another reason you could use? So I've written both reasons down, but they can sometimes give you one reason and ask for the other. So it's good to just kind of be imaginative. So anyways, that would be x is equal to 119 minus 73. Oh, this is embarrassing. That should be... $45 degrees? 46 degrees. Whoops. Slightly embarrassing, but yeah, 46 degrees. Again, these questions are really quick once you know to use the circle theorems, right? Like, that's the hard bit, is seeing the circle theorems. The actual maths isn't that bad. It's just the circle theorems. But I'm glad you both saw that. It's really, really good. Really, really, really good. Okay. So once again, we do have a chord and a tangent. So we might be using the alternate segment theory. Might be a silly question to ask now, but are you both okay with what a segment is? Sorry, a chord is. So a chord is just a line going from 2 points on the circumference that's not through the middle. Okay, good. Probably should have asked that a long time ago, but you know. Okay. Cool. Let's have a look at this question. A, B, and C are points on the circumference of a circle centre O. DCE, so is a tangent, yeah, good. AB is equal to BC, good. BCE is 65 degrees. Work out the size of the angle AOC. Okay. So the angle they're looking for, kind of annoyingly, is this angle here. Okay. It's kind of frustrating that they've used that angle, but you know, is what it is. Let me think. Okay. This should be fine. This one's going to be kind of hard to picture. I've worked it out in my head. It's going to be a bit hard to picture. For now, I'm going to get rid of that symbol, but just remember what angle we're looking for, okay? I'm just going to get rid of it for now. Hope that's okay. So first things first, I said about alternate segment theory. This angle is 65. The opposite angle would be this one here, which is 65 degrees. Is that all okay? Okay. Now, if this is an isosceles triangle, both of these sides are the same, but it also means both of these angles are the same. They're both 65 degrees. Okay? What's up, Evie? Oh, perfect. Okay, cool. Okay. Now here is where I can imagine... Oh, thank you. It's okay, I'm getting views anyway, it's all good for me. I appreciate the sentiment though. So, here's where I can imagine a lot of students getting stuck. I can imagine most students getting this, a few less getting this, but this is where it's like, well, what do I do now, right? I completely understand. So if you're ever stuck, right? And this is the best advice I can give you. If you're ever stuck, work out anything, right? Because A, you might be... Hold on. Bear with me 1 second. Yeah, okay, perfect. Where was I? Okay, so if you just work out anything you want, you might get method marks, which is a win, and you might find what the answer is. Okay? So, if I look at this situation here, what can I work out? Well, I can work out this angle here. Right? So why don't I do it? Again, it's a 4-mark question. At the moment, I've probably got 2 marks. Right? So we get 1 mark for this and 1 mark for this. Let's see if I can get a 3rd mark. I'm going to work out what this angle is here. And this angle here, let's call it angle X. X would just be equal to 180 minus 65 minus 65, which is 50 degrees. Okay? Not 100 degrees. Oh, are you saying what the answer is? Well done. Well spotted. Good job. Okay? So we now know that that is 50 degrees. Yeah. Sorry, Evia. You actually were a bit faster than I was, okay? Now, I'm going to get rid of everything else on here. Okay? So what we have, what we've just worked out, and again, well done, Evie, for spotting this. That's 50 degrees. Now, what's the angle I want again? The angle I want was this angle. Let's call it Y. Right, I know that I called the other thing X. Let's change that. What does that look like? That looks like the whole angles at the center are twice that at the circumference. So in other words, angle Y is twice angle X, so 100 degrees. Okay? Because again, they're made up, it's 2 angles that are made from the same points, right? A and C. One is at the center of the circle, the other one's at the circumference. So one is going to be twice, double the other. Okay? So again, in finding that 50 degrees, we discovered what the actual answer would be. So this would actually be our other 2 marks. Lila, are you okay with that? Are you still processing it, maybe? Okay. B, C, A. Okay. Yeah, good question. So, let's go back slightly. It's a really good question. So first off, I'm assuming you're okay with this being 65 degrees, right? That's cool. Can you try in your mind to get rid of the line going from O to C? And can you see that's just a big triangle now, right? If you ignore the line O to C, big triangle. It's isosceles because these 2 sides are the same, which means the base angles are the same. So they're both 65. So again, if you try and ignore this line, these 2 angles have to be the same because it's an isosceles triangle. Are you comfortable with that? No worries, it happens to the best of us. Trust me, okay? I couldn't subtract numbers earlier just now, so it's completely fine. Yeah, well done. And good communication, by the way. When you ask questions, you're very pointed, okay? Which is good. And again, classic example. Let's read the question first, actually. I'm not going to jump ahead. Like, I get a bit excited sometimes. A, B, C, D are points on the circumference of a circle centre O. ADC is 118 degrees. AOC is x degrees. Find the value of x. Okay, first things first. This quadrilateral here is not a cyclic quadrilateral. Okay, that inner bit. So what some people say... Yeah, fair point. What some people say is x is just equal to 180 minus 118, which is 62, because opposite angles in a cyclic quadrilateral add up to 180. This is completely wrong. For a cyclic quadrilateral, all 4 points have to be on the circumference. So this thing is a cyclic quadrilateral, not this thing. Okay, well, let's think about, if we're not sure what to do, again, follow the advice we just figured out, work something out. Well, I can work out this side for the reasons I just said, right? So y is equal to 180 minus 118. And it doesn't say to write your reasons, but I'm going to write my reasons. And I'm just going to say that opposite angles in cyclic quadrilateral add to 180. Okay, so far so good. Now what's this? Well, we have 2 points, yeah? And these 2 angles are made from the same point, and one of them's at the center. Well, that means x is going to be twice y, which would be 124 degrees. For the exact same reason as this one. Both okay with that? Perfect. So I just want to remind you, in your actual exam, and I want to point this out, is 10% of your marks have to be unseen questions. So you might get a circle theorem that is ridiculously crazy, you've never seen it before. It will be a 5 or 6 mark question, okay? In that situation, just work out something and you can scrape together some marks. Getting 0 out of 6 is far worse than getting 2 or 3 out of 6. So yeah, just try and work anything out. We'll probably have time for one more question. Actually, before we do anything, can I ask, is there anything you want me to go over before the end of the lesson? So are all of the circle theorems okay? Are you fine with them? Do you understand it? Is that all okay? So again, is there anything you want me to go over? Because I will have to go. Yeah, you're all good. Evie, are you okay with everything as well? Technically, I should be leaving now, but I'll carve out some extra time just to do one more question. Because this one looks a bit spicy, I'm going to say. Okay, all good. I'm really glad to hear it. This is a very difficult topic. This is a hard question to finish on, so that's good, right? And we want to work out angle ACO, so this angle here. Yeah, good. So if I look, okay, cool. So they want to find this kind of... Okay, my words escaped me for a second. This angle in this big triangle, right? Now, can you see that this is an isosceles triangle? And I've also just made another isosceles triangle. All of these sides are all the same. Good so far? Perhaps I should stop asking that repeatedly. But if these 2 sides are the same, then this angle here is also 27 degrees. Okay. And something else that I can probably do... okay. So I know what to do next. It's just I'm worried about writing this a bit poorly because it's going to get a bit messy. The other thing, right, is we have a chord and we have a tangent. So I'm hoping we've programmed ourselves to now think alternate segment theory. Alternate blah, 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 blah. The angle we have is 53. So can you see that this overall angle here will also be 53 degrees? Okay. In terms of our working, how many marks is this? 4 marks. Okay, that's a bit... Is that okay? Because again, it's the opposite angle. The total thing's 53. The inner bit's 27. Perfect. Okay, good. Now, can you see that means this angle, so just the angle OAC, is going to be 53, the total angle, minus 27? Is that okay? I'm taking this a bit slowly, I know, but I just really am kind of conscious that I might not be doing this in the most easy to see manner. Okay, good. And because OAC is 26 degrees, then the angle ACO is also 26 degrees because it's an isosceles triangle. Okay. Is that all okay? That's the answer, by the way. 4 marks, not bad. But honestly, there's a lot of steps there. There's a lot of steps. So for this last bit, the reason would be base angles in isosceles blah 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 are equal. And the other one before is when we said 53 degrees, we should say that that's the alternate segment theorem. The rest of it, we don't actually need to write reasons for, okay? We all okay with that? Any questions? Oh. I think that was a pretty productive lesson. We've done a hell of a lot. Got it all? Yeah, perfect. Evie? Yeah? Well then, circle theorems are officially done. What I would recommend is, because this is very, very difficult, is go on something like Maths Genie or Physics and Maths Tutor, and every now and then try and do a question or two. Okay? But again, I do upload this to YouTube anyway, so you can just look through it again if you want to. But that's what I'd recommend so you don't end up forgetting it. Other than that, I really appreciate you guys joining in. Again, feel free to share this around and everything, because it's always better with more people in it. And yeah, I hope you have a really good evening, and I'll see you next week. Perfect. You're very welcome, both of you. Thank you for coming. Perfect.